Hi, I would like to go over one problem from your textbook on page 654. It's problem 16.30. And this problem, I have to read it carefully, using the average baseball salary for 2000 through 2013 data from problem 16.18 on page 646, which the data is stored in a file is known as a BB salaries. We would like to do the following. First, part A, fit a third order autoregressive model to the average baseball salary and test for the significance of the third order autoregressive parameter using alpha zero point zero 0.05. Then it's asking us in part B, if necessary, fit a second order autoregressive model to the average baseball salary and test for the significance of the second order autoregressive parameter, again alpha as zero point zero 0.05. And then in part C, it's asking for, if necessary, fit a first order autoregressive model to the average baseball salary and test for the significance of the first order autoregressive parameter when alpha is zero point zero 0.05. And lastly, in part D, forecast the average baseball salary for 2014. It means basically you have to go to third order, second order, and first order and see which order would be more uh, precise or um, significant, and choose that one to forecast the average baseball salary for 2014. So let me go to StatCrunch, and let me use StatCrunch to do the problem. Obviously, I'm going to try to retrieve data from your textbook. So StatCrunch has the ability to uh, retrieve the data from different chapters. And now, if I go to chapter 16, BB salary is right away here. And eventually the data is here. The first column consists of year 2000 from 2013, and then the average baseball salary. So let me try to create my data set by copying this column and having it one leg down, and that's going to be useful for first order, leg down for the second order, and lastly, three leg down for the third order autoregressive. So now, if I'm interested in third order autoregressive, this would be my data set. So let me copy this and put it right here. And this is actually my yt. It would be yt minus 1, yt minus 2, and this is yt minus 3. So I'm going to try to run a autoregressive based order 3. And so in order to do that, I'm going to go to stat. And there is a strong connection between autoregressive model and regression model. So I'm going to go to regression and ask for multiple regression. My y variable, if you look carefully, I stored it in variable 10. So that would be right away here. And my x1, x2, x3, they are here. This is my like x1, this is like my x2, and this is like my x3. So I'm going from 11, 12, and 13. And right away, I could ask for running regression. So it's going to go through, and eventually it comes up with a different parameter. This is my y-intercept. This is slope for yt minus 1. This is slope for yt minus 2. And this is slope for yt minus 3. And eventually, if you look, it has a p-value for all of them. The only one you really at this time you're concerned is this one, 0.6963. Because the problem is asking you to run a test for third order autoregressive. So let me go to PowerPoint and perform that test. Actually, if I write down the autoregressive model, this would be my model. And under HO, I have a slope for the third order autoregressive is equal to 0. If I use your book notation, they use A3 equal to 0. Under alternative, slope for the third order autoregressive is not equal to 0. It means A3 is not equal to 0. Remember, alpha was 0.05, and my p-value was 0.6963. And therefore, by comparing alpha with p-value, since p-value is larger than alpha, I'm going to come up with a do not reject HO decision. And therefore, my conclusion would be basically what I am saying, the third autoregressive slope is statistically 0. So it's not a good model. The third order autoregressive model is not appropriate in this case. And now going back to the problem, if you go back, they ask him to run a second part, be second order autoregressive. So let me try to do that. Now, in order to run a second order autoregressive, this would be my data set. This much. So let me copy this and let me put it somewhere here. Go to somewhere here and copy and paste it. So now this is my YT, and this is YT minus 1, and this would be YT minus 2. And now again, I'm going to try to run a multiple regression for the second order autoregressive. So I'm going to go to regression. Now remember, I stored my YT, which is the same as Y, in column V variable 20. So let me grab that one. And then I'm going to try to come up with my X variable. It's in 21 and 22. So I select those two. And again, I'm going to run a regression now. Now, again, if you look here, this is my y-intercept. And this is my slope for first one, lag 1, yt minus 1, and this is slope for yt minus 2. And remember, if I need to come up with statistical tests, I have a t-value for each, and I have a p-value for each. If I am testing for the second order autoregressive, this becomes very important, this p-value 0.6264. So let me go back to PowerPoint, and based on the second order autoregressive, first I can write down my model. This would be my model. And then if I'm running a test for the second order autoregressive, again, similar to the third order autoregressive, I'm going to run a test and set up the hypothesis. Based on HO slope for the second order autoregressive is 0. Actually, if I'm using your book notation, that would be A2 equal to 0, and A2 is not equal to 0 under alternative. Alpha is still 0.05, and my p-value, if you recall, is 0.6264. Again, my decision would be do not reject HO, since my p-value is larger than 0.05, and therefore I can conclude the second order autoregressive is not appropriate, it's not significant. So that is going to take me to part 3, actually. And I'm going to go back and see if I can run the test for part 3. So now let me go back to my original data and try to grab enough information to run a first order autoregressive. For first order autoregressive, I need a lag 1. So this is my data set. So let me copy that and let me put it somewhere far, far away from the rest. I'm going to put it right here. So this is my YT now, and this is YT minus 1. Now, if I'm running a regression, it will be like a simple regression. This is like my Y variable. It's column is like my y variable, and this column would be like my x variable. So again, I'm going to go to start. I'm going to go to regression, and this time I can use a simple regression. So when I'm using simple regression, it's asking for my x. It's going to be variable 31. And it's going to ask me for y, that's variable 30. And then I can run the test. So again, it comes up with my regression, auto-regression equation or autoregressive model. And it comes up with statistical test for slope. My t-value is 7.027. I can get that by dividing 1.079 over 0.153. More important, my p-value is almost 0, 0.0001. So let me go back to PowerPoint. And now I can first write down the first order autoregressive. Yt is equal to minus 0.04793 plus 1.079 yt minus 2 minus 1. And then if I run a statistical test, this would be my test. Average O slope for the first order autoregressive equal to 0. That should be A1. And under alternative, the slope for first autoregressive is not 0. That should be A1. It's not equal to 0. Again, alpha is 0.005. And the p-value is almost 0.001, I think, if I recall it correctly from the previous one. So if I go back, I can say that, yeah, 0.0001. So I go back, and that's almost close to 0. So by comparing these two alpha and p-value, I can come up with decision of rejecting HO. So when I'm rejecting HO, it means the first order autoregressive is not equal to 0. It means it's significant. It means the first order autoregressive is appropriate to be used, and I can use that for forecasting. So this is going to be my model, my suggested model. And in order to predict for year 2014, that's what I have been asking partly, all I need to do is write down this equation and plug here the value for 2013 instead of yt minus 1. So if I go there, and my prediction should be y, for 2014 is going to be minus 0.04793 plus 1.079 multiplied by what was the actual value for 2013, which based on my data set was 4.25. So eventually my prediction for 2014 is 4.537. So my prediction for the average baseball salary for 2014 is 4.537. Thank you for watching. If you have any questions or concerns, please email me.